Hi everyone, my name is Tiger and I will introduce the distributed deep learning framework in our project. In application, sometimes we need to analyze large datasets with large-scale models, and training large models can be very computationally expensive. And one way to accelerate the training process is to use multiple servers to parallel the training. That's the motivation of our project. And first, let's recall the data parallelism. The idea is that the gradient of the objective function can be expressed as some weighted average of the gradient of function Li, and the function Li only depends on some subset of the samples. So we can launch one node to evaluate the gradient on that subset. That's the idea of data parallelism. And we will use the ray to provide the parallelization support for needle. First, we need to parallelize the forward and backward path for each subset in this ray task function, and then it will return the individual gradient on each subset. And then we use this aggregate gradient function to compute the average of the gradients and update the parameters. So in one epoch, suppose we want to run SGD with 1,000 mini batches, and we may split that 1,000 samples into several subsets and launch one node to evaluate the gradient on each subset. This is realized by calling the ray task function here. And then we can call it this aggregate gradient function to collect the gradients and update the parameters. And let's see the performance here. So we run the experiments with number of nodes 1, 2, 4, 10 respectively, and the results are summarized in this plot where x-axis is the time and y-axis is the loss. And you can see that if we assign more nodes to evaluate the gradients, we can reduce the training loss faster. And we will also try to implement model parallelism in the following week. Thank you for listening.